The mystery. Nobody questions about the ancient towers of historic buildings. You pass by historic buildings constructed between 1850 and 1920 in European and American cities and see ornate metal rods projecting vertically from ancient rooftops. A tour guide explains confidently, lightning rods installed after Benjamin Franklin's revolutionary discovery. An explanation universally accepted without question. No one doubts it. No one investigates further. But if you carefully examine original architectural documentation from the period, meticulously preserved maintenance records in dusty municipal archives, and detailed technical publications by reputable contemporary engineers, you will discover that many of these imposing structures had significant additional functions, extensively documented, not unfounded speculation, not fanciful conspiracy theory, verifiable historical fact in official public records. Between 1840 and 1920, approximately a period of 8 decades, hundreds of public and private buildings in Europe and America were intentionally equipped with sophisticated systems that captured electricity from the constantly present natural atmospheric electric field. Systems operated commercially, providing reliable supplemental current for essential emergency lighting, charging storage batteries, and precision scientific instrumentation, some for verifiably documented decades. Then they mysteriously disappeared completely. Not only was the technology gradually abandoned, but knowledge about it was almost entirely forgotten. Today, the vast majority of people, including highly qualified modern electrical engineers, have no idea that such systems ever existed operationally. The profound, intriguing question is not merely that these systems existed historically. Archival documentation is absolutely clear on this. The truly fascinating question is, where did they go physically and conceptually? Why did they disappear so completely and quickly that even collective memory was erased? The answer is not a dramatic Hollywood conspiracy about the suppression of revolutionary technology by vested interests. It is a more interesting and deeply instructive story about how technologies emerge, serving specific needs, serve a genuine purpose in a specific historical context, and then inevitably disappear when that context fundamentally changes. A story that reveals much about how technological innovation actually works versus how we imagine it works. This roadmap will follow a trail of evidence showing exactly what happened to atmospheric capture systems, not through vague claims, but through specific, verifiable documentation, installation records, technical publications, patents, engineers' correspondence, archived corporate decisions, and it will reveal not a sinister mystery, but a convergence of economic, technological, and social factors that rendered functional but limited technology completely obsolete within 2 decades. A process that happens repeatedly in the history of technology but is rarely documented so clearly. Let's start with evidence of what actually existed before exploring where it went. If you're intrigued by the question of how documented functional technology can disappear so completely that even memory is erased, and want to explore through verifiable evidence, not speculation, what really happened to atmospheric energy harvesting systems, leave a like showing interest in real technology history. Subscribe for investigations based on factual historical documentation that reveal patterns about how innovation really works. Turn on notifications so you don't miss analyses that use specific cases to illuminate general principles. If you value research that goes to original archives instead of repeating simplified narratives, click the Hypar button supporting work that brings accurate history grounded in primary evidence. Let's trace exactly what happened, documenting what really existed before the Wadatich disappearance. First, let's state unambiguously what existed. The Brevoort Hotel in New York installed an atmospheric collector system in 1895. This is an unverified claim. The March 1895 issue of the technical magazine Electrical Engineer published a 3-page article with a detailed technical diagram. It depicted a 60-foot metal tower on the roof, a radial network of copper conductors, and a connection to a lead-acid battery bank in the basement via a voltage regulator manufactured by Westinghouse specifically for the application. During favorable conditions, the system provided supplementary current for charging batteries used for emergency lighting. Hotel maintenance records preserved in the New York City archives mention quarterly checks of the atmospheric collector and battery system from 1895 to 1902. In 1902, the hotel was renovated and the system was removed. The reason documented in correspondence from the manager to the owners was, with the recent connection to the municipal electrical grid, the atmospheric system is no longer necessary, and roof space will be used for other purposes. The Blue Hill Observatory in Massachusetts installed the system in 1885. Founder Abbot Lawrence Roch kept meticulous diaries preserved in the observatory's archive. Daily entries from 1885 to 1903 include measurements of atmospheric collector current, along with temperature, barometric pressure, and other meteorological parameters. A typical entry from March 15, 1887, clear sky, northeast wind, 12 mph, temperature 45 degrees Fahrenheit, pressure 30.1 inches, atmospheric collector current 0.8 milliamperes at 60 volts, sufficient to maintain battery charge of recording instruments. The system was used regularly until 1903, when the observatory received a connection to the electrical grid. The last entry on the collector is from June 14, 1903. Atmospheric collector permanently disconnected. Instruments now powered by municipal line. A textile factory in Lyon, France, belonging to Établissement Duclos, installed the system in 1888. The catalogue of the 1889 Paris Universal Exposition includes an entry, Établissement Duclos, Lyon, uses ground-based electricity capture for supplementary lighting of administrative offices, reducing dependence on a steam generator during periods of reduced operation. The company published a technical report in 1892, available at the Bibliothèque Nationale, documenting annual savings of approximately 40 francs in fuel, attributed to the use of the atmospheric system. The system remained in operation until 1905, when the factory was connected to the municipal grid. Correspondence from a technical director to an electrical equipment manufacturer, dated March 1905, states, "With the availability of reliable current from the municipal grid at a reasonable price, we have opted to discontinue the atmospheric system. Equipment will be removed and sold as copper scrap." These three examples are representative of dozens similarly documented. The pattern is consistent. Installation between 1880 and 1895, operation for multiple years, removal between 1900 and 1910 when network connectivity becomes available. Tracking the exact moment when technology started disappearing. The transition was not gradual. It was concentrated in a narrow window from approximately 1895 to 1915. We can trace it precisely through multiple lines of evidence. First line, publications in technical journals. Between 1870 and 1895, Electrical Engineer, Electrical World, and similar journals regularly published articles on atmospheric capture, an average of 8 to 12 articles per year. After 1895, the frequency begins to decline. 1900, 6 articles. 1905, 3 articles. 1910, 1 article. 1915, 0. Not only frequency, but tone changes. Pre-1895 articles discuss new installations and technical improvements. 1895-1905 articles frequently mention the discontinuation of existing systems. An article in the July 1903 issue of Electrical World, titled "The Decline of Atmospheric Systems," observes, "With the rapid expansion of municipal electrical distribution networks, atmospheric harvesting systems that were economically justifiable for isolated buildings are being removed in favor of more convenient and reliable grid connections." Second line, patent records. Between 1860 and 1895, the United States Patent Office granted an average of 4 to 5 patents per year related to atmospheric harvesting. After 1895, the number declines rapidly. 1900, 2 odd patents. 1905, 1 patent. 1910 onwards, essentially 0. The last significant patent is number 784-219, granted to Hermann Plausen in 1905. Even this one acknowledges emerging obsolescence, stating in the text, "While centralized generation makes such a device less practical for general use, it may still find application in remote locations." Third line, catalogs from electrical equipment manufacturers. Companies like Westinghouse, General Electric, and Siemens published annual catalogs listing available products. Catalogs from the 1890s include sections on atmospheric capture equipment with specialized voltage regulators, high voltage capacitors, and other components. The 1892 Westinghouse catalog dedicates 4 pages to atmospheric equipment. The 1900 catalog, 2 pages. The 1905 catalog, 1 paragraph. The 1910 catalog, no mention. Evidence is clear. Technology did not gradually disappear over the centuries. It disappeared rapidly in a window of approximately 2 decades, coinciding precisely with the expansion of municipal electrical grids, revealing specific decisions that eliminated systems. One by one, the disappearance was not accidental or mysterious. It was the result of conscious decisions documented by building owners and facility managers. We can trace the logic through corporate correspondence and records of decisions. The Trinity House Archive, the UK Lighthouse Authority, contains detailed correspondence about atmospheric systems installed as emergency backup at various coastal lighthouses during the 1880s. A technical director's memorandum dated 15th April 1898 states, atmospheric collector systems at Cornwall and Devon lighthouses have been maintained at an annual cost of approximately 12 per installation for inspection and replacement of deteriorated components. During 3 years of operation, systems provided backup power on exactly 2 occasions when the main generator failed. With recent improvements in generator reliability and availability of spare parts, atmospheric backup represents a cost that is no longer justifiable. I recommend the removal of all atmospheric systems and the sale of recovered copper. The recommendation was approved. Systems were removed in 1899-1900. The Blue Hill Observatory Archive contains an exchange of letters between the director and the administrative board in 1903. The director proposes maintaining the atmospheric system even after connection to the grid for the continuity of scientific records of more than 18 years. The board responds, although we appreciate the value of data continuity, the cost of maintaining an atmospheric system in addition to the grid connection cannot be justified given the limited budget. Priority should be given to the main meteorological instrumentation. The system was disconnected. Corporate records of Établissement Duclos preserved in the Lyon Regional Archive show a cost-benefit analysis prepared in 1904, comparing maintenance of the atmospheric system versus total dependence on the grid. The analysis calculates annual cost of atmospheric maintenance 35 francs, annual savings in grid electricity 40 francs, net benefit 5 francs. But the analysis notes, a net benefit of 5 francs does not justify the complexity of maintaining 2 separate systems. Operational simplification through the elimination of the atmospheric system has value that exceeds the small financial savings. Decision: remove the atmospheric system. Repeated pattern: atmospheric. Systems had value when they were the sole source or when the grid was unavailable. Once a municipal grid became available and reliable, the marginal benefit of a supplementary system did not justify the maintenance cost and operational complexity. Following the physical destination of removed equipment and components. What physically happened to equipment when systems were dismantled? Records reveal specific fates. Most metal components were sold as scrap. Copper had significant value. Metal towers were dismantled and sold to scrap yards. Records from the Brevoort Hotel show the sale of an atmospheric collector tower and associated copper conductors to the New York Metals Company Recycling Company in August 1902 for $47, a substantial amount. Capacitors and batteries had varied fates. Some were reused in other applications. The Blue Hill Observatory Archive mentions that atmospheric system batteries were transferred for use in a new municipal mains-powered emergency lighting system. High-voltage capacitors were sometimes sold to educational laboratories for physics demonstrations. A catalog of used equipment published by a scientific supplier in 1906 lists high-voltage capacitors previously used in atmospheric capture systems suitable for electrostatic experiments. Specialized voltage regulators generally had no resale value. They were too specific for their obsolete application. Most were discarded. Only a small fraction of the equipment was preserved. Some components entered science museum collections as historical curiosities. The Deutsches Museum in Munich acquired a complete atmospheric system from a building in Stuttgart in 1908, which is still on display. The Science Museum in London has components of a Cornwall lighthouse system in its collection, although not on permanent display. But the vast majority of physical equipment was recycled or discarded. Physical evidence of systems has almost completely disappeared, except for towers and rods that were occasionally left in place by inertia, but mentally reclassified as just lightning rods. Discovering why technical knowledge has also disappeared. The disappearance of physical equipment is understandable, but why was technical knowledge also so completely forgotten? Engineers who designed and maintained systems had detailed expertise. Why wasn't it passed on? First reason, obsolete specialization is not taught. Electrical engineers were trained in technologies that had a commercial future. Once it became clear that atmospheric harvesting had no future in the era of electrical grids, it ceased to be included in engineering curricula. Examination of electrical engineering manuals shows a change. Manual of Electrical Undertakings, published in 1895, includes a chapter on atmospheric harvesting systems with 23 pages of technical information. The 1905 edition of the same manual reduces it to 4 pages with a note, included mainly for historical context as such. Systems are rapidly being replaced. 1915 edition, no mention. Second reason, engineers with expertise moved to other areas. Letters from engineers of the period show a transition. An engineer who had designed atmospheric systems in the 1890s wrote in a 1906 letter preserved in an archive, "My work is now entirely in the design of distribution systems for municipal networks. Knowledge about atmospheric capture that I acquired years ago has no application in current practice." Expertise was abandoned because it had no continuing professional value. Third reason, technical documentation was intentionally not preserved. Companies that removed systems discarded manuals and specifications. There was no reason to keep documentation for equipment that no longer existed. Corporate correspondence occasionally survived in general archives, but specific technical documentation was eliminated. Fourth reason, cultural memory is short. The generation of engineers who worked with atmospheric systems retired or passed away in the 1910s, 1930s. The next generation never saw systems and had little reason to ask about them. By 1940, atmospheric capture was a historical curiosity known only to a few specialists in the history of electrical technology. The combination of these factors erased technical knowledge almost as completely as physical equipment was recycled. Examining how historical narrative has been simplified and distorted as direct memory faded, the history of electricity was simplified. Atmospheric systems were edited out of the standard narrative. History of technology books published after 1920 rarely mention them. When they do, it's usually as a curious footnote. Example, A History of Electrical Technology, published in 1962, devotes 400 pages to the development of electrical generation and distribution. Atmospheric harvesting receives 2 paragraphs. In the late 19th century, there was brief interest in harvesting electricity from the atmosphere for practical use. Some experimental systems were built but proved impractical and were quickly abandoned with the advent of centralized generation. This description is technically correct but deeply misleading. Systems were not experimental but commercial, operating for years. They did not prove impractical, but were replaced by superior alternatives. Quickly abandoned obscures the fact that they functioned for decades in some cases. Simplification created a vacuum that was filled by exaggerated alternative narratives. In later decades, claims about suppressed free energy frequently cite atmospheric systems as evidence. But these claims distort historical reality as severely as the simplified mainstream narrative. They allege that systems could provide unlimited energy and were suppressed by conspiracy. Actual documentation shows that systems provided watts or tens of watts, not kilowatts, were supplementary, not primary, and were abandoned for practical economic reasons, not conspiracy. The true story is more interesting than both simplified versions. It shows real technology functioning within real limitations, serving a genuine purpose in a specific context, and then being replaced not because it was a fraud or a conspiracy, but because of a convergence of economic and technological forces that made a superior alternative available and accessible. Analyzing economic forces that ensured obsolescence. The disappearance of atmospheric backup systems was a result of specific quantifiable economic changes. First force, declining cost of grid electricity. In 1895, municipal grid electricity, where available, cost approximately 20-25 cents per kilowatt hour, a substantial amount. By 1905, competition among suppliers and economies of scale had reduced the cost to 8 to 12 cents. By 1915, it was 5 to 7 cents. While the cost of grid electricity fell, the cost of maintaining atmospheric backup systems remained constant or increased as components aged and expertise became scarce. Second force, dramatic improvement in grid reliability. Early municipal grids were notoriously unreliable. Interruptions were common. In this context, atmospheric backup systems had real value. But as generation and distribution technology improved, reliability increased dramatically. Between 1895 and 1910, the mean time between grid interruptions improved by a factor of approximately 10. Atmospheric backup became unnecessary. Third force, increased electricity demand. As more electrical appliances became available and desirable, the demand for electricity from buildings grew rapidly. Atmospheric systems providing 10-50 watts were useful when total demand was 100-200 watts. When demand grew to kilowatts, atmospheric contribution became insignificant as a percentage. Fourth force, opportunity cost of capital and space. Atmospheric equipment occupied valuable space, particularly on the roofs of urban buildings. As urban real estate values increased, the opportunity cost of dedicating space to equipment that provided declining marginal value became unsustainable. Fifth force, operational simplification. Maintaining two separate electrical systems required duplicated expertise and management complexity. As organizations sought operational efficiency, eliminating redundant systems became a priority. The convergence of these forces was inexorable. It did not require conspiracy or suppression. It simply made it economically irrational to maintain atmospheric systems. Once, a superior alternative was available at a reasonable cost. Revealing lessons about the life cycle of all technologies. The history of atmospheric systems is not unique. It is an exceptionally well-documented example of a pattern that constantly repeats itself in the history of technology. First lesson. Technologies can be functional and based on sound science, but still be completely superseded. Functionality does not guarantee survival. Context determines viability. Second lesson. The window of economic viability can be narrow. Atmospheric systems were viable approximately from 1880, when necessary components became available, until 1910, when superior alternatives became widely accessible. A 3-decade window in an industry that is now over a century old. Third lesson. The death of technology is generally the result of thousands of independent rational decisions, not a single dramatic event. Each building owner, each facility manager made an individual decision based on specific economic calculations. The aggregate of these decisions was complete obsolescence. Fourth lesson, the disappearance of technology erases not only equipment, but also knowledge and memory. Expertise is not preserved when it has no application. Documentation is not maintained when it has no value. Cultural memory is surprisingly fragile. Fifth lesson, the historical vacuum created by forgetting is filled by simplified or exaggerated narratives. Both obscure a more interesting and instructive reality. Sixth lesson, fringe technologies of a bygone era contain insights into how innovation truly works. Not through suppressed revolutionary discoveries, but through incremental evolution responding to constantly changing economic and technological conditions. Seventh lesson, preservation of detailed technical history requires intentional effort. Without dedicated historians delving into archives, even significant chapters of technological history can be lost. Atmospheric systems survive in the historical record only because some documents were accidentally preserved in general archives, not because there was a conscious effort at preservation. Connecting forgotten past to disappearing technologies today. The standard that eliminated atmospheric systems is active today with current technologies. We can observe examples in real time. Fax machines were essential for business communication in the 1990s. The decline began with email, but accelerated dramatically with cloud-based document sharing services. Between 2000 and 2020, fax use in businesses fell by approximately 80%. The technology didn't stop working. It was replaced by a superior alternative. In 20 years, it will be a historical curiosity known mainly through jokes about obsolescence. DVD players were standard in computers and homes in the 2000s. Video streaming eliminated the need. Sales of DVD players fell by 90% between 2008 and 2020. Manufacturers stopped including them in laptops. In a decade, it will be difficult to explain to young people why we needed physical discs to watch movies. Manual transmissions in automobiles are disappearing as automatic transmissions improve and electric vehicles become obsolete. In 1980, 35% of cars sold in the US were manual. In 2020, less than 2%. The ability to drive a manual, once essential, is becoming a rare specialization. Dedicated GPS devices like Garmin were billion-dollar products in the 2000s. Smartphones with integrated navigation eliminated the market in less than a decade. Companies that dominated the market had to completely reinvent themselves. The pattern is identical to atmospheric systems. Functional technology serves a genuine purpose, then is replaced not because it fails, but because a superior alternative emerges. The difference is speed. Atmospheric systems took 3 decades to disappear. Modern technologies can become obsolete in 5 years, but the fundamental mechanics are the same. Understanding to predict technologies that will soon disappear. Knowing the pattern, we can make educated predictions about what will disappear in the next 2 decades. Passwords, as the primary method of authentication, are beginning to disappear. Biometrics and passwordless authentication are superior in security and convenience. In 10 to 15 years, typing a password will seem as obsolete as an atmospheric system. Physical credit cards have a limited lifespan. Smartphone payments and biometrics are eliminating the need for physical plastic. The transition is accelerated by the pandemic. which sped up the adoption of contactless payments. In 15 years, physical cards will be the exception, not the norm. Dedicated television remote controls are disappearing as voice control and smartphone integration become standard. Sales of universal remote controls have already fallen 60% since 2000. Physical car keys are being replaced by smartphones as keys. Several manufacturers already offer this. As the vehicle fleet is renewed, physical keys will become obsolete in 10 to 15 years. USB-A cables are being replaced by USB-C. The transition is 70% complete in new devices. In 5 years, USB-A will be a legacy port found only on older equipment. Each of these technologies works perfectly well today. They are not being abandoned due to failure, but because of a superior alternative. Standardization is exactly what eliminated atmospheric systems, functional but not optimal in a changing context. In conclusion, what forgotten history teaches us about real innovation? Returning to the original question, where did atmospheric energy go? Literal answer, it was recycled as scrap copper sold by the pound. But a deeper answer, it disappeared because the economic and technological context that made it viable evaporated within a 2-decade window. The history of atmospheric systems teaches that technological innovation does not follow a simplified, heroic narrative of revolutionary discoveries fighting against suppression. It follows a more complex and interesting pattern of solutions emerging for specific problems in specific contexts, serving a genuine purpose, and then being replaced as the context evolves. It teaches that functionality is not enough for a technology's survival. Economic context, available alternatives, and greater momentum for change are equally important. It teaches that the disappearance of technology is generally the rational aggregate of rational individual decisions, not conspiracy or error. It teaches that knowledge and memory are surprisingly fragile, disappearing within generations when there is no economic reason for preservation. It teaches that gaps in historical memory are filled by simplified or exaggerated narratives that obscure more instructive reality. And it teaches that preserving detailed technical history requires conscious effort, because natural inertia is to forget what has no immediate utility. The value of understanding this pattern isn't nostalgia for lost technology. Atmospheric systems were inferior to electrical grids in almost every relevant aspect. The value lies in understanding how innovation truly works, so that we can navigate current and future technological change with open eyes, recognizing that technologies we depend on today will likely disappear in the same way, leaving future generations wondering how we lived without what they consider essential. If this investigation into how documented functional technology can completely disappear through economic and technological forces, not conspiracy theories, has expanded our understanding of how innovation truly works versus simplistic narratives, please like this video supporting historical research that goes to original archives. Subscribe to continue exploring patterns of technological change through specific, verifiable cases. Click on the video appearing on the screen for more primary evidence-based technology history analysis. Thank you very much for your time dedicated to understanding how the forgotten past illuminates the present and future. See you in the next document-based investigation.